we're going to do optimization, meaning that we're going to maximize things that need to be maximized. Meaning, if we have a business, we'll be maximizing the profit, or we'll be minimizing the loss in our business. So, without further ado, let's just look at the questions. The first thing says, or firstly, let me say we're given the cardboard box in the flat form, and then we know that the original form of it is this one here, which we can put our tools inside. So the first part says find the volume of the box, this box over here. It means firstly you have to determine the dimensions. Here it could be x, here could be 4, 5 minus 2x, 6, 3 minus 2x, and then you know the volume that it is equals to L multiplied by B multiplied by H. The H could be our x, base could be the 45 minus 2x, 63 minus 2x. Now I can try to simplify it. So when you are trying to simplify, you find out this will be the answer. That will be the volume in terms of x. So the other question says, show that the stationary point of the volume occur at this equation, which is equals to x. Here, let's first try to find dv over dx. So it could be 12x to the power of 2 minus 2 multiplied by this, we're going to get 2, 3, 4 x. For this part you can just write this constant as 2, 8, 3, 5. Now let's check this 12 and this 3. What happened? We divided this whole thing by 4 in order for us to get to this point. We can say divide by 4, divide by 4. So we know that the stationary points of this volume are the turning point of our function, where the slope equals to 0. So without wasting time, let's look at P.S-scie. P.S-scie says find the value of x where the volume is stationary. We can use this equation or this equation, doesn't matter. And then we can solve for x. Let me just use the quadratic formula. It says x equals to -b plus or minus square root of b squared minus 4ac 2a. As you substitute everything that you have, you are going to find out this will be your values of x. So let me put a restriction over here. Let me say when I double the value of x, it shall not be greater than this number, which is 45. We can count it as centimeters because you can see here it is included as a length. So even here it's a height. So we can say this shall not be greater than this value. Now let's look at the other question. that says find the maximum value of the volume and justify that it is indeed maximum. Here, let's look at the first part of the question, which says find the maximum volume. I can use this value and substitute it on this equation. So after substituting, when I use my calculator, I'm going to find out that the maximum volume is 10,948.8. Now let's look at the other part of the question, which says justify that it is indeed maximum. What does this mean? It means when you take the second derivative of that function and substitute the value of x, you are going to get a value less than 0. A value less than 0. So let's say the second derivative of the volume would be given by 2 times 12 will be 24 x minus this, we just write the constant as 4 3 2. Now let's substitute whatever we have. 24 multiplied by 8.53 minus 4 3 2. When I used my calculator, I'm going to get that thing as 227 negative, 227.28. So this will be your answer. Now let's say we have a cylinder and then we're given the volume of it as 480 centimeter cubed and the radius as x. The first question says find the area of the cylinder in terms of x. Firstly, I have to determine everything in terms of x. It means I shall not involve h as a variable. So let me just say, let me find the value of h first, because I know the volume equals to the area of the base multiplied by height, and the volume I know that it is 480 centimeter cubed equals to x squared multiplied by pi multiplied by h. Now the h value would be 480 over x squared multiplied by pi. I know that there is no top, it has an open top. It means we are not going to involve the other circle when we write the area. So we know that the area of the cylinder equals to, without an open top, would be 2 pi r multiplied by h plus pi r squared. We were going to involve 2 over here if we had the other top. So let's substitute whatever we have. 2 pi x multiplied by 480 over x squared multiplied by pi plus pi multiplied by x squared. Now let's try to simplify it. Let me write it over here. So the x on top will go with 1x at the bottom. So it will be left with 2 multiplied by 480 over x. So 480 is 960. 480 multiplied by x is 960 over x plus pi r x squared is the area. Let me get rid of this. So the other question says find the values of x where the area is stationary. So let me use this equation. Find the derivative. Let me write it as 960 multiplied by x to the power of -1 plus pi x squared. Let's find the derivative of the area. So it will be -960 x to the -2 plus 2. So when you are doing a thing, this will be the derivative of the area. Now you can equate it to 0 to solve for x. It will be 960 over x squared plus 2 pi x equals to 0. Multiply everything by x squared to have 960 plus 2 pi x cubed equals to 0. Take this to the other side or add 960 both sides. Now you're going to have 2 pi x cubed equals to 960 and divide everything by 2 pi to have x cubed as 480 over pi. Now the value of x could be the cube root of 480 over pi. Now you find out this will be the value of x. So let's get rid of everything that we won't need now. So the other part of the question, or the other question says find the minimum value of the area that is in, and justify that it is indeed minimum. So what is the area? The area is this value over here. So the area could be equals to 960 over this 5.35 plus pi multiplied by 5.35 all squared. So when you're doing the calculations, you find out the minimum area is 269.36. Now the other part of the question says justify that the area is indeed minimum. So you have to note that if the second derivative of the area is greater than 0, this thing is minimum. For maximum, the second derivative of the area should be less than 0 when you substitute this value of x. So let's try to find out that, or prove that, the area is indeed minimum by finding the second derivative. Now, as we know the first derivative of the area, let's find the second derivative. 2 multiplied by this, negative 2 multiplied by this value will be negative 960 multiplied by 2 will be 1920, or 1920 x to the negative 3 plus 2 pi. Now let's substitute the value of x. 1920 As you are doing the calculation, you're going to find out the answer could be this one, which is greater than 0, which proves that the area is indeed minimum. Now let's look at this object. This object consists of two objects which are combined, the half of the sphere and the cylinder, which has no top. It means we are not going to involve this part over here, or the circle, when we write the area of it. So let's check what is given. We are given the volume of the object, which will say, or let me just write the volume of the sphere first, as 4 multiplied by pi r square. Normally it's 3, it's over 3. So it means here, because we're talking about the half, it's going to be 2 on top. We divide everything by 2. So it's gonna be 2 pi r cubed. And then let's check the volume of that thing. The volume of the cylinder can be pi r square multiplied by h. And then we can combine these things as we have this thing. We could say 2 over 3 pi r cubed plus pi r square multiplied by h equals to 2880 pi. Now let's solve for h, because we want to make everything in terms of radius, or r. Let's take this to the other side. Pi r square multiplied by h equals to 2880 pi minus 2 over 3 pi r cubed. Now let's remember that we're looking for the area of the object. It means it's the combination of the area of the sphere, which has only one circle, and I meant to say a cylinder with one circle and the half of the sphere. Now let's try to solve everything. Area is going to be equals to pi r squared plus h 2h multiplied by pi r plus 4. We're going to divide it by 2, which will be 2 multiplied by pi r squared. So these things are the like terms. Means it's going to be 3 r 2 pi 3 pi r squared plus 2h pi r. Let's substitute whatever we have now. It's going to be 3 pi r squared plus 2 pi r. Let's simplify the area. 3 pi r squared plus. Now you can see that this and this are the like terms. Let's combine them. So 3 is going to be 3 minus 4 in my head, which is 9 over 3. Will give me 5 over 3. So I shall say 5 over 3 pi r squared plus 5, 7, 60 pi over r is the area. So I found the area in terms of r. Now let me get rid of things that I won't need. For the equation says, show further than the total surface area is minimum, where h equals to r. The first thing that you're going to do is to derivate this and equate it to 0. And then the thing that you can do is to solve for r. So let's look at this thing over here. So dA over dr is going to be given by 2 multiplied by this thing is going to be 10 over 3 pi r plus. Here it's going to be negative 5, 7, 60 pi over r squared. No. And then find the second derivative, because we are proving that this is the minimum thing. Now you can see the value of x by using the first derivative by equating it to 0. So it means now you have to multiply everything by r squared. And then you're going to get 10 over 10 over 3 pi r cubed minus 5, 7, 60 pi equals to 0. You can take this to the other side, for it should be 10 over 3 pi r cubed equals to 5760 pi. Divide everything by the 10/3 pi. Now you can take cube root both sides. And my answer now the answer SR can be 12. Now let's substitute this to prove that the area is at minimum. We can say 10/3. Let me change your color for this. 10/3 pi plus 11520 pi multiplied by 12. So using your calculator, you'll find this as the answer, proving that because the second derivative, when you substitute the value of r equals to the number greater than 0, it means the same, it is minimal. But now let's show that it is where the value of h equals to r. So how can we do this? As previously, we know that the value of h equals to this thing over here. Now we can substitute the value of r, as we are proving that the area is at minimum when the h equals to r. So we can say h equals to 2 minus 2/3 pi multiplied by 12 whole divided by pi multiplied by 12 square. Here is cubed. Now let's look at this part. 2880/12 square going to give me 20. And then for this part, I can say here it's made by 4 multiplied by 3. This 3 can go with this one. And then 2 multiplied by 8. 2 multiplied by 4 is 8. Now I can say this is 12. So that will be your answer. Thanks for watching the video and consider subscribing to my channel.